Simple rules of differentiation, example 3. Find the gradient of the tangent to the curve, given here, at the point where x equals 9. Now remember, this is all about finding gradients of tangents. It's what it's set up to do. So what we need is the gradient function. Now the first thing to do is rewrite this using our knowledge of indices. So root x, that's going to be 4x to the half. Take away 1 over root x. Remember, that's 1 over x to the half. So that's 4x to the half. Take away x to the negative a half. You really need to know your indices in order to do this topic. I'm now in a position to differentiate. So dy dx is going to be, half comes down and multiplies. Half of 4 is 2. Reduce the power by 1. So that's going to be negative a half. Here the negative a half comes in front and multiplies. So effectively negative 1. So that's going to be plus a half. Reduce the power by 1. So this is going to be 2 divided by the square root of x plus 1 over twice x to the 3 over 2. So that's going to be 2 over root x. Now let's think about x to the 3 over 2. That's x to the 1 multiplied by x to the half. So I could write that as 1 over 2x root x, or there's other things that we can do as well. We know our index laws, so let's do that as the square root of x, which is then cubed. So we know a to the m over n is equal to the nth root of a to the power m. So I'm using that there. So now we want when x is 9. Now there's a special notation for this. We use this line here, which is called a given line, and then we put x equals 9. So this reads the gradient function given that x equals 9. So that's going to be 2 over root 9 plus 1 over twice the square root of 9, then cubed. So that's 2/3 plus 1 over 2 multiplied by 3 cubed, which is 2/3 add 1 over 54. Now 3 times 18 is equal to 54. So what we need to do to get both of these over 54 is multiply top and bottom here by 18. So that's going to make that 36. So that gives us 37 over 54.